I'm Anthony Mayas. I'm a senior software engineer in the AR team at Niantic. Today, I'm going to build a prototype that I call the Yeti Cannon. So I want to build an application where when I tap on the screen, it just shoots a whole bunch of Niantic Yetis. You recognize it has the very basic, a directional light. It has an AR scene manager, which is a prefab that's been grabbed from the ARDK assets that have been imported. And for the rest, I have a small canvas with just a little shoot button that I already prepared before the video. And that's it. There is really nothing else. If I build this onto a phone, it will just show the image of the camera and the shoot button, and it will do nothing. What I'm going to do first is attach the cannon to the camera. So when we shoot Yetis from the camera, we want them to be shot in the direction that we are looking at. In the inspector of my camera object, I'm going to add a script that I already prepared and that I will show. So I called it shoot projectiles. It takes a prefab that's going to be the object that we shoot. And then we have set projectiles per shot, a force of 1, and a spread of 0.2. The spread is how much it scatters. So a low value will be narrow and a wide value will be wide. I'm going to attach a prefab to this, in particular the Yeti. So in my game object selection, I'm going to go to assets here and I'm going to scroll down to the Yeti. So the difference between the Yeti and the small Yeti is that for the Yeti, the small Yeti, it has a capsule collider and a rigid body. And so those are elements, components that are made by Unity. And the capsule collider that you see here as a green outline around the Yeti is the area that will cause collisions. And the rigid body is what gives the Yeti a mass and essentially makes it fall with gravity. So if we go back to the scene on my camera, my script is set up to shoot 7 small Yetis every time I tap the screen. So I'm going to just hook my shoot button to that behavior. So I'm dragging in the unclick the AR scene camera and shoot projectiles, shoot. And we're going to see what it does. Play and shoot. Boom, 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 boom. Boom, boom. Shoot the Yetis. Now, if I build this, this is what it's going to look like. And if I shoot, you see the Yetis just completely fall through, which is still fun, but you'd want them to interact. In order to do that, it's pretty simple. What you have to do is add a mesh to the scene. So looking for all the prefabs that you have, you tap AR mesh, and this is provided by the ARDK. So you just drag and drop it into the scene. And so this AR mesh has an AR mesh manager that essentially will configure how you want your mesh. 20 frames per second is a bit high, so I like to decrease that to 10 or 15. For the mesh prefab, the mesh chunk is the provided prefab by the ARDK, but I made my custom one, and so I'm gonna say it's the base mesh here. If we inspect it real quick, it's just a simple mesh render, and I have a very nice Fresnel and normal color coding combination that will look very pretty. Back to the mesh. Meshing requires depth. So in order to do that, we go back to the AR scene camera and we add a component that's an AR depth manager. This AR depth manager will ensure that depth is estimated on the device. And in this particular case, I'm going to disable occlusion mode because otherwise it will conflict with the rendering of the mesh. In the editor here, it's not going to make any difference, but on device, it's going to look more like this. So I go back to the same area with the stuffed animal, but this time you will see that pinkish and greenish mesh appears. And that's what the mesh is. As I shoot, you see that all my Yetis are actually falling through it. So there is no physics interaction. It's purely rendering, and it occludes those Yetis that are falling through. And the whole reason for that is that in the base mesh prefab that we use, we are missing a mesh collider. So I have another version here, the collider mesh, which is exactly the same thing, except it contains the mesh collider. And so what that mesh collider does is that it ensures that the geometry that's coming from the system is going to be used for physics interactions, and in particular with all the colliders and rigid bodies of the Yetis that we fire. In our case, enabling physics is as simple as replacing the prefab here. And once I do that and run it again, we obtain the collisions that we wanted, and we have a much richer and much more fun experience. So the mesh appears again, scan a little bit, and then you see like all those Yetis are just accumulating all over the place. And as simple as that, that's how you can add physics of the real world to interact with all your virtual objects. It's a lot of work to redeploy to the device every time you want to test a small change. So for that reason, the ARDK comes with what we call the Virtual Studio. It is a set of tools that enables editor testing, and that includes a lot of functionality that normally would only be available on device. One of them is the mock meshes. It is possible to capture a mesh on device and save it as a file to load it later in the editor. And for that, in the ARDK examples, under contextual awareness and under meshing, we have a scene called Mesh Saver. In the Mesh Saver, if you build that one, it will look something like this. So you see that at the bottom, it has a bunch of buttons. And one crucial button is Save Mesh File here. And when you tap it, it will save the current state of the mesh into a file. And all you have to do is connect your device to your computer and navigate to your phone's file system. And once you obtain that file, it creates a .bin file. So this is one of those. So what you can do is copy them into your Unity project. And then in order to integrate them into the scene, you have to create a new empty game object. So I like to call them mock mesh and adding a component mock mesh here. So mock mesh takes two parameters. One is time to discovery, which is how long it will take for the object to appear. I like 1/2 second because I'm impatient. And for the path, all you have to do is right click here, copy path, come back here, and copy the path to that file here. The mesh will only appear in the editor. The mock mesh system, like any mock system in the editor, is designed so that it just doesn't run at runtime. So you can leave that in to do in-editor experimentation. So now I'm going to play, and you will see that 1/2 second after hitting Run AR, the mesh appears. And we also have like a very nice like WASD interface to move the camera around. This is the mesh saver. I'm going to do that again in the Yeti Cannon scene. And I'm going to copy this here and go back to my project. Don't save, that's fine. Paste here, and I'm going to run again. And this time, if I hit shoot, you can see that like the Yeti Cannon is operating entirely in the editor with a mesh that was copied. So that way you can that way you can tweak and make quick iterations. Simple example, what if instead of 7 projectiles, I wanted to do 20, I can hit play again and immediately see the effect. That's all there is to it. Thank you for following along today. And I hope that you have fun building cool AR experiences with the Lightship ARDK.